Let us integrate our wave function, plotting and expectation values into our code now. So we are having psi and en. So first thing is we can make it psi n, that is a psi new. So we decided that we'll have a zeros and we will write in terms of n number of zeros by n minus 2. That is, number of rows will be equal to 11 and number of columns will remain as 9. And n is basically will take care of that, because n is whatever is the length of this vector, that will automatically decide the n value. And then we said that psi n of between 2 to 10, that is between 2 to n minus 1, that is a row, and columns will change from 1 to 9, which is n minus 2. So columns will be same. So for these values we will keep it as psi itself. Okay, so that takes care that psi n is correctly obtained. Then once we get the psi n, so for plot we had to use x transpose, because x is a row vector. So x transpose comma psi n of colon comma 1, and so that gives us the first plot. Now what we can do is we can copy this and paste it and change this to 2, and we can plot in red color. Again copy it, change it to 3, maybe we can plot it in green color. Like that we can always get the various plots. And once we get the plots, we also want to check the norm. So norm is already existing, I think, so let's call it as norm 1 is equal to sum of control V. Okay, so that doesn't work. So sum of psi n of colon comma 1 dot star psi n of colon comma 1. So that is psi star psi, and so now we can do one thing, we can display this. So disp command is like this. So norm equal to comma norm 1. So it will display the value of norm. And similarly we can calculate the expectation value of x, and that was the same thing. So we can copy this, control V, sum of, here we have to add x transpose dot star, and similarly we can display this expectation value of x. Say equal to comma expectation value of x. So let us now run this code, and so what will happen to the output? Now instead of psi we can send the output as psi n, and so save and execute. Now let me copy that command, what we want to execute. Control C. So here we are putting 0.1, a equal to 1 and v naught equal to 10 power 6. So now this is our potential. Why did the other plots didn't come? Yeah, so what you can see is norm has come out to be 1, expectation value of 0.5, and all the column vectors are the way they are supposed to be, and these are the energy eigenvalues. Everything has come, only the plots of the wave functions. This was the old plot and the new plot didn't come. Okay, yeah, here I made SCF, that is set current figure, as 1, and here before we plot we can put SCF as 2, set current figure as 2. So you have two different plots. So now if you were to, let us put a semicolon so that we don't need to see the output. Now you can see that we have got both, right? So we have got the potential plot also, and we got the wave functions also, and here we can see norm equal to 1 and expectation value of x equal to 0.5. So now this is working. So the next thing that we need to do is check how can we improve the accuracy of the energy eigenvalues. So there we discussed that only the first 2-3 values are really good, after that they become very poor. Okay, so we have to first give the analytical expression and then cross check analytical and analytical expression energy eigenvalues and the what we obtained from the simulation. Okay, so that we will see next.